Okay, hi everyone. Thanks for joining us. Just give me a quick chat or a post in the chat if you can hear me, and you love to hear where you're from. If you want to do that in the chat, and yeah, really appreciate you joining us today. Today we're going to be talking about compliance matters, building codes and standards.
I'm Clara. I'm from Canberra.
Nice to meet you. Anyone else joining us from interstate or Sydney?
Won't hold that against them.
No, that's it. No, we actually do some work in Canberra. All right, let's get into it. Okay, so a little bit about us, just a quick slide. Dan Ray, we're a specialist remedial sort of waterproofing contractor. We're a building practitioner under the New South Wales Design Build Practitioners Act. We specialise in waterproofing remediation work, and the type of work we specialise in are actually flat roofs. However, we do all the remedial work around that too. So we do a lot of balconies, podiums, etc. And we work in generally New South Wales, Canberra, now Melbourne, and we work across various industries, strata, commercial, and government. Yeah, so I've just been through that. That's our. We also do adding to that. We also do preventative maintenance as well. So we do regular checks on membraned roofs to ensure their compliance and long-term warranty periods as well, that they're still viable. My special guest today is Mr. Ron Caruana. If you haven't noticed already, it's actually my father who founded the company. G'day, Ron.
How are you all?
I'll let Ron give the quick intro.
Yeah, as Daniel mentioned, I'm Daniel's father. I started Dan Ray originally with my wife, and as we went along, Daniel come on board, and Renee, my daughter, as well. So they've actually taken over Dan Ray and running with Dan Ray now, and I've verged out with another company called Waterproofing Compliance, which we look into new buildings and remedial buildings as well, but make sure that they do new buildings follow the new act, and they do comply with both the Australian waterproofing standards and the NCC. And then we get involved in sometimes with remedial work where we investigate issues on existing buildings. Yeah, I've been in the game for quite a while, and yeah, so I know quite a bit of the problems that happen on buildings.
Nice. So yeah, we're gonna jump into today a lot of the sort of standards and codes that apply to waterproofing. So what and it's a little bit in depth, but I'd like to also ask that if you've got questions that come up as well, put them in the Zoom chat, and then we'll do our best to answer them. If we can't answer them today, we'll if you leave us your details, we'll also respond as well and give you some answers or more detailed if you need to. Okay, so let's jump into it. So where do we see references to waterproofing? Starting with the National Construction Code. So the National Construction Code, for those that aren't aware, essentially governs all of the sort of construction in across Australia. It's the document or documents that actually override any of the standards below that are referenced, right? So this is sort of our governing document that we use, so where are the references in particular to waterproofing? So Volume 1, Class 2 to 9. So Part F1 in the code, F1D5. So it talks about any external horizontal surface above ground is waterproofed as per AS 4654.2, which is the external waterproofing standard for design and installation. And the other part in volume 1, part F2, is where you'll find the building elements of wet areas. So what's classed as water resistant and waterproof. So I will cover that in some of the terminology in the next few slides. Do you want to cover volume 2? You want to just go through that?
Volume 2, yeah. Volume 2 mainly relates to class 1 and class 10. Well, basically housing and that and
Single dwelling.
Yeah, single dwelling. What's the name? And they basically go into slightly different different views of the waterproofing methods and installation, but they still follow the main waterproofing standards, internal and external. Okay.
You've also got the Australian Building and Codes Board housing provisions that also gets referenced as well for internal wet areas. In the main, so the main reference standard when it comes to waterproofing is AS 3740, which is for internal wet areas, and AS 4654, which is for waterproofing above ground. Externally, correct. So to go deeper into that, so what are the specific standards in waterproofing? So as mentioned, AS 3740 is the internal standard for design and installation of internal wet areas, right? So bathrooms, laundry, etc., all your wet areas internally. 4858 is actually the standard in which a membrane must be tested to for use in internal areas. So why that's important is every membrane must be tested to a certain class, and I'll cover that in a minute of essentially, how much does it stretch, basically, how much does it, the extensibility of a membrane, and whether it can be used in an internal area.
And they also do tests on the actual membranes themselves, chemical tests that could happen across in a bathroom, for example, in the shower, using bleachers and things like that, and how they withstand those typical normal use areas.
Yep. And then you've got AS 4654.1, which is the same, which is similar. So it's the standard that the materials or the membranes are tested to for use externally above ground. And then you've got the AS 4654.2, which is the design and installation for a contractor to install those membranes. At the moment, there's no Australian standard for below ground. However, they're adopting, or they're looking at adopting the British standard 8102 for below ground waterproofing. Just a little note also that I've got on here is the MBA, the Master Builders Association, also have some very relevant guides to waterproofing. And also the Australian Concrete Remedial Association has a course for remedial waterproofing as well. So very, very good course. Okay, so in the standards, what are the terms and what's used in regard to waterproofing within the standards? So first one, there's been misconception around interchanging of certain terms, and I wanted to sort of put some clarity around these terms. So waterproof, a waterproof material is that does not allow moisture to penetrate that material, as opposed to water resistant, which doesn't degrade if water enters the material. So that's a very because the reason I bring this up is that concrete is considered to be water resistant. So a lot of in construction that term is interchangeably used with certain substrates. So it's important to note the difference. And then the waterproofing system is a combination of the building system to ensure there's a waterproof barrier. So that's important as well. So it's not just the membrane itself. It's actually a full design of the system. And then there's terms that are also used, which is may, shall, and should, which is essentially referring to, so for example, you may get a sentence that uses either of those terms that essentially applies if it's a option, mandatory, or a recommendation. So an example would be in the external AS4654 standard, it says that there shall not be ponding on a roof or on a substrate, but it should have 1 to 100 fall. That's just one example. So it's in short, it's important that those terms are interpreted correctly. Yeah, so this slide shows the classes of membrane and their extensibility. Do you want to talk to that one about different types?
Yeah, well, generally, the membranes are classed, have their actual class ratings, right? So when you decide to pick a membrane for a particular job, it's got its class rating on it, and depending where it's going to be used. And basically, they rely on the elongation. In other words, how much it can stretch before it actually tears or cracks. Okay, so and what it is too, the lower the class, the more like corner fillets you need to have, different sizes that will allow the membrane to work better. Like, for example, the liquid membranes do not like a 90-degree transition between the horizontal and vertical. So it's very important to look at what class membrane you've got and how these are treated. In some cases, because if you're getting a class 1, it's a pretty extensive corner fillet, up to about 75 mil, I think it is, on a class 1, in which case it's tremendous. So some suppliers will recommend possibly using a bandage in the corner, and that will give them the flexibility they need in the corner to comply with their requirements. That's important that you look at that. And again, the different classes of membrane will give you that, which Daniel's got there on the side, the class 1s, 2, and the examples of them. Again, you tend to pick the right membrane for the right, whatever you're protecting, really. The risk factor is important, because while a lot of people look at the membrane being cheap, what's a cheap membrane I can use? Cheap is not always cheap, because if it fails, the remediation work is horrendous. So you're better off spending that little bit extra in the beginning, and gives you longevity in the long run.
Awesome. So I'll go into now in reference to certain areas of a building and how they're referenced within the standard. So key items for balconies and roofing are in 4654. So one is falling to the drain, and how the membrane is actually laid. So as you see on the diagram on the far left, the preferred fall is 1 to 100. And the sheets should be staggered. So you should not have a joint that goes all the way through. So it should be sort of laid in a brick fashion, with the fall or the lap of the membrane falling towards the drain. And also with drainage points, we find this is quite common on older buildings where they don't use a clamping style drain that actually clamps the membrane and pushes the membrane against the substrate on the drain design. And and so I've already mentioned the lap. So the fall should fall to the drain as well. Terminations. This is a diagram out of the standard as well. For sheet membrane, this is a preferred sort of termination where you essentially regular cut into the vertical wall or parapet wall, and you're essentially the membrane system is then inserted into that regular cut. As you can see here, this diagram has an overflashing. That can be done with certain membranes as well. Some membranes have a weldable profile that the membrane welds onto as well in that situation. Do you want any other comments on that?
Yeah, this is the preferred method because some of the termination relies solely on sealants, and they've only got a lifespan sometimes of about 2 years. maybe 3.
Yes, I'll show you this one.
Yeah, well, that's this one here. I'm talking about.
Yeah.
Yeah, so this is, sometimes they say, well, not to cut into the wall and whatever, but however, this type of pressure seal system relies extensively on the sealant. And as I mentioned, that's only got a lifespan of about 2 years, 3 years, generally, okay? And which means that maintenance comes into it and you need to check them and redo them as well.
Yeah, so this detail from the standards, that's typically used on a torch-on, where the torch-on will turn up the wall and then the profile is fixed to the torch-on, and then sealed off with a sealant. So what we see, a common defect is actually the wrong sealants used on the membrane. So they use a say for example, a polyurethane sealant, which is not ideal to be used with a bitumen membrane. So there's things like that, and like Ron said, it's very reliant on the sealant, as your main sort of waterproofing barrier on the upturn.
Yeah, there's got to be a separation between the sealant and the torch-on. With torch-on being bitumen, they have a reaction. So you need to use either the correct sealant for the correct membrane, basically.
Okay, balcony detail. So a very, very common defect that we see on balconies is along the door threshold. So the diagram on the left is straight out of the standards on what a typical membrane installation would be, as you can see by the dark sort of dashed line there. Most waterproofing, unfortunately, only turns up the vertical face and doesn't go sort of under the door threshold. We find that in remediation situations that's why the door or a lot of design consultants will ensure that the waterproofing turns up underneath the door threshold. That's why the doors have to come out. So that would be the ideal detail. And I've drawn the red line there. That's essentially where the common fault occurs, is along that joint where there's essentially a cold joint will form due to building movement. I don't know if you want to comment more.
Yeah,
on the door
well,
threshold.
that fault there that Daniel's showing with the red line, right? That dotted line is that some of the hobs are poured later, or you can either have a hob that's poured in situ with the main slab or additional after. And that's a common problem with the after effect, okay? Because the hob moves and cracks, and if the membrane is not suitable, it will come through there. Another problem is the waterproof angle now is installed now under standards, but it wasn't installed before. So if there's an issue with the door or there's a problem with the door, it'll work in that area there. It'll leak through there. Okay, so now with the new standards, I mean, that's one typical detail, but there's about two or three details like that. And basically, if you do just turn up and you've got enough termination height, you still must install the angle at the back, no matter what.
Yeah. So the key thing too, as Ron mentioned there, it's it's important to note the height of the where that water stop's got to finish. So that will be that you determine that by your the wind rating in the appendix. So sometimes you've got enough height on the hob where that is, you won't need to do that because you've got enough height on the hob. So that's just a small note there to take into account as well.
But but again, that does improve your height, but the water stop angle still has to be installed.
Yes, correct. That's right.
All right, irrespective. Okay, but that gives you the added height, as long as the membrane terminates on that angle. Okay, so you can achieve more termination height with the angle if the membrane goes onto the angle. Okay, it's always where the angle where the membrane finishes. So if the membrane just finishes up on the face of the hob, that is your termination height.
Yeah, that's it. You want to cover this one?
Oh, and sorry, and the other drawing again, that's from the standard as well. That's when you have the situation when you have the external and internal the same height. Okay, so in which case you need to have, again, you can see the termination that it's using the water stop angle there. You can see that behind on the right hand side again.
Yep.
But it's relying on the drain to basically take up any excess water near the door. Okay, but it must fall, the external must fall away from that drain. So you don't fall the deck into the drain. That is there as a protection for the door. Okay, it must fall towards the drains, the floor waste or other strip drains you may have on the external balcony or terrace.
Yeah, so the other common defect is we find that the external height is higher than the internal. So you end up getting water flow into the unit because the heights are out as well. But yeah, that's for balconies. Let me hopefully clear this. State. That's all right. Okay, planter boxes. Oh, let me just give it. Yeah. Planter boxes. So this is planter boxes. While they look nice, they're obviously a problem in a lot of apartments and apartment complexes. So this is straight out of the standard as well. And as a remedial contractor, and I'm sure Ron also we've never probably seen a planter box design this way.
No,
I don't think.
No.
In an actual construction environment. So a couple of things to note would be one of the common things we see would be the issue of the soil height, so in the membrane height. So often the membrane finishes below the soil height. That we see that quite a lot, and obviously then you're getting moisture drawn into the parapet wall or the upturn. And this is never we don't see this design done either, where the membrane carries up and over and outside. But if you want, I don't know if you want to talk about how that's detailed correctly then in a normal build.
Well, yeah. Well,
Yeah.
basically in a lot of new buildings, especially, they look at the aesthetics, okay? And while that's good, you still you need to maintain the proper waterproofing scenario. So where you turn up the walls, either way, you can but you must go above the soil height at all stages, right? But you go and terminate the membrane above the soil, and then you can overlap that membrane with another membrane that could be colored or painted over or rendered over, and to tie into the building, the rest of the building, okay, and give you the same result, but maintaining the proper waterproofing. The center drain, those clearing out access there. Also, if that serves two purposes. If for some reason around the drain blocks, water can drain into it, and plus also where the drains are, so you can access them and clean them out if you need to, or if you have a big problem, dig them out, but you know where the drain is. Currently, it's any man's guess. Like you don't know where the hell it is.
Yep. Awesome. Okay. All right. Internal wet areas. So specifically in internals, and I want to reference a couple of the terms in the standard too, because these are new in the 2021 internal standard. So they've got a few now. They've increased the definitions of a lot of terms, which is actually really good. So for those that are new to like liquid membrane, and the terminology used around that, the dry film thickness is the finished thickness after the membrane cures. So there's a lot of misconception around in when applying liquid membrane. A lot of contractors aren't actually testing the thickness. So that's in the built environment, new build especially. They're not getting the correct thickness when they've finished a liquid membrane installation, which is essentially what you test for.
That's what we test for. I mean, when the contractor is actually applying the membrane, there's what they call a wet film thickness gauge, okay, which they can test the application or do spot checks while they're applying the membrane. However, a lot of contractors don't use it or don't know how to use it properly, because a lot of the membranes like you go, for example, a water-based membrane that could have up to 50% evaporation rate to get to the dry film thickness. Okay, so you might apply 1 millimeter thick wet, but it'll end up being 0.5 dry. Okay, and then if the supplier wants a 1 millimeter finish, that means you need to apply basically 2 millimeter wet to get to the final thickness.
Yeah.
Now, and that's all. Also, that thickness is important because the membrane has been tested under those two standards we mentioned previously, under the 4858 and the 4654.1. Okay, they've been tested for that certain thickness. So if that membrane is 1 millimeter thick, it's tested for 1 millimeter. So it's basically the elongation testing, chemical testing, all that's done on that 1 millimeter thick membrane. Once you deviate from that, then the warranty or the the durability of the membrane is deteriorated. So our job as a compliance consultant, basically a waterproofing consultant, we go out to site after the membrane's been applied, and we do checks using ultrasonic meters. Sometimes we do destructive testing if we're a bit skeptical about the situation, and then do a report accordingly. But we find a lot of the thicknesses is out.
Yeah, the other issue with and I've included in here are the stages of curing time too. So liquids will go through certain stages of curing. If it's not fully cured and that membrane is covered by either a screed or some other form of bonded final substrate, what can happen is this process can reverse, which is called reemulsification. So essentially water or moisture gets reabsorbed back into the membrane and it turns back into its original form. So that's where we find that issue happens in new build, where they're really pressed for time and they're getting other trades in too quickly before the membrane's fully cured as well. The other small thing I'll mention too is in the internal standard, it does actually specify the membrane over or under the screed, not both. So your primary membrane must be over or under the screed in the Australian standard as well.
And your main membrane has to be falls. Has to have a fall in the membrane. Okay. So it's not illegal to use the two, but it's not mandatory to use two. You use one or the other, but as long as the membrane falls to the drain. That's the most important one.
Yep. And these were the gauges that Ron was talking about with testing the thickness or the wet film thickness during installation. That's what you would use, some kind of wet film comb.
So those combs, those combs are showing the notches there for wet film thicknesses, and then the corner is actually showing you the fillet required depending on the type of membrane.
Right. It's okay, I'll skip these. Oh yeah, so internally the Australian standard, they've also classified the three categories of risk. So for example, high risk would be in the shower itself, moderate is outside or adjacent, and then low risk is no falls required. So they're the sort of categories that they've put in place to govern the falls in internals. The last thing in internals would one of the major issues is the water stop angle in the shower. We find that in construction, a lot of the times the height of the angle, the water stop angle, is not sufficient, but the tilers have gone over that anyway, and so it allows water to escape the shower. You've seen your share of internals.
They just put any angle, and the tiler goes ahead and tiles everything, and you can't find the angle. And what happens is moisture tracks along the tiles, underneath the tiles, across the top of the angle, and ends up, in some cases, they've even tiled it higher than the door angle, which means it travels outside the actual wet area, which is a very, very big problem. So again, while we're engaged to go and check all these things, we pinpoint and highlight these issues that the builder has to rectify. Otherwise, it's too late.
Okay, the final one, testing. So Ron, you probably want to talk to this slide because you use an integrity scan system, right? So so the DTEC system your company uses.
Yeah.
And I thought I'd put this slide on how do you test? What do you use to test, and what are the advantages, disadvantages?
Well,
of some of the,
for the external
Yeah.
membranes, this is mainly for external, the Integra system. You can use it internally, but it depending on the area you've got, right? But either way you can, because it uses a roller. That's a machine there showing the blue machine, which does larger areas, and then there's a roller system that does internal systems. So we can do walls and whatever. Okay. And we use that purely for breaches. So either pinpointing a pinhole in a membrane, which is, it's very effective. And it uses water to spread over the membrane, and the water will track into any voids. So it does an electrical current, low voltage, but it makes a contact between the basically water penetrating into the earth of the building. That's how it works, and then sends off a signal. Okay, so it pinpoints defects in laps and holes, and it's very effective in doing that.
Awesome. So we're coming up to time now. I'm happy to take some questions. Either if you'd like to unmute or post it into the chat, we can answer a couple of questions for a couple of minutes. I know we've just sort of run out of time, so if you need to leave, thank you so much for attending. And we'll stay on for a little bit longer and answer some questions if everyone's okay with that.
We've had a couple of.
Yes, we've already had a couple. So
we've had 4 questions. So a couple, I'm not too sure actually what they're getting to, but we've got Phil sent in. If there is water seeping through outside brickwork, how would you know where the water's coming from? Like shower, water basin, toilet, even the laundry. Okay, well, being an outside brickwork, I'm assuming there's a cavity. Okay, so water's tracking along the cavity. So you need to know roughly where this water is exiting from. And usually from that, you can determine what's likely. But what you can do, you can also do water testing using dye in the actual area. Like you might want to test the shower or around the toilet area. We also can do pressure testing on the actual pipework. So if you put a pressure meter onto the pipework, you can see if you've got a leak in the walls, for example. Like you've got your main water pipes, possibly a breach. That happens often sometimes. Okay, so by checking the water pressure, you can say, okay, there's a down pressure. That means water's seeping out somewhere else rather than your shower or whatever. But yeah, it means basically testing, really. Now, Leonard, how are older buildings, balcony waterproofing remediation works ever comply when works would be structurally very invasive and prohibitively expensive? Well, we try. Remediation is very hard with the new compliance. We're trying to work around these. There are ways to work it out sometimes, and in some cases we can do performance solutions, depending. Of course, you can't, start chopping existing building slabs and all this, otherwise you've got a structural issue then. But there are ways to work things around if we need to, and hence that angle. Sometimes what we were saying behind the doors and all that gives you a termination height increase, and that can sometimes help you. Okay.
Yeah, so in remedial, while Ron does it, you do a lot of design performance for new builds.
For new builds and that, yeah.
So from a remedial contractor, we're very much governed by the designer, so the design practitioner in New South Wales anyway. So it's important that there is a compliant design in place, because that is you want to make sure that the repair work that you're doing is as per the code, right? So that's the way it stands right now.
So we had one question from Wesley, and basically he sort of mentioned that where contractors allow or not allowed to do. Well, like Daniel mentioned, right, in remedial work, you can't touch nothing without a design practitioner, basically. Okay, and you can't do patch. You can like previously you can get a waterproofing contractor up there, have a look at it, dig out a couple of tiles and patch it up. That's not allowed anymore. Okay, you must get it checked by a design practitioner, do a design, and then get a building practitioner to do the work who will engage a waterproofer or whoever trade they need to remediate the work. This jumping around and grabbing anywhere that comes off the street is not allowed anymore, because that's why we've had a lot of problems. And we've come across a lot of strata companies and that have tried that, not knowing the regulations, and have been caught with people doing work only 12 months old and still leaking.
Yeah.
Okay, so you got to be very mindful of that. And also, under the new legislation, strata companies, body corporates are all liable to take on this type of thing without the proper regulations. Okay, so you must be very mindful of that.
Is there any further questions that anyone
Yes,
would like to
please.
post in?
Yes, I'd like to ask a question.
Yes.
On the liability, so what you're saying is this is a unit complex. We've got ponding issues. We know we have a level problem in terms of fall. We certainly don't have 1 in 100. So what you're saying basically is that it has to be a fully professional job to get this fixed, so that we are in compliance. This is in the ACT, not in New South Wales.
Okay, yeah. So the ACT currently is not, while it's not governed by the Design Build Practitioners Act, it is advisable to ensure that your remediation is compliant, but it should be compliant, right? The other states, it's a work in progress, but I know that Victoria and Canberra are already in process of actually looking at their version of the New South Wales Design Build Practitioners Act.
Right. So what exactly does the non-compliance mean then, if it was to be done that way? Not that I'm suggesting that it would be, but just so that I'm clear, because it would be good to explain to people who don't understand that this is a big job that's got to be done.
Well, Claire, isn't it? Yeah.
Clara?
Yeah. Clara?
Yeah. We had one situation where a building, same thing. A contractor came in and said, "Look, if we use a PVC membrane, the water can pond on it. There's no issues because the membrane can take it." But technically, it's not correct.
That's not compliant.
Because the National Construction Code says you have to have a fall. Now, the National Construction Code, that's Australia-wide, not in New South Wales. Okay, so you can automatically then become, it's not compliant, and you can have warranty issues and a lot of other issues come to play then. Okay, so ideally you get a reputable contractor that knows what they're doing. They'll make sure that you've got fall, the membrane is installed to fall, and they'll pick the right membrane for your situation. Otherwise you're taking a gamble. Okay.
Thank you. That's very helpful. Thank you very much.
Yeah,
no problem. Anyone else? Well, I'll maybe stay on for a couple more minutes and then we'll wrap it up. All good? All right. Well, awesome. There's our details on the screen there. So please reach out if you've got any questions you weren't sure about, or please drop us a line. And yeah, appreciate everyone's attendance. Really appreciate it. Look out for the next one.
thank you very much.
Thanks, everyone.
Take care.